Today we're going to take a look at section 1.9 that deals with inverse functions. Now again, the book gets into quite a bit of math speak on this, but honestly, it's one of the easier sections overall. Looking at inverse functions, the idea is, in order for two functions to be inverse, when you do the composition of the two functions, in other words, when you plug in one function to the other, it should just end up giving you the identity. It should just leave you with x, nothing else. Doesn't matter which way you do it, you should get that x, if they are inverses. Notation-wise, we'll usually use, try to lock that focus, we'll usually use this inverse of f, or f inverse, said a couple different ways, but it looks like f raised to the negative 1 power. It's not actually raising to that power. It means that inverse. Okay? And that's usually the notation I'll use, is the inverse of f. So, if I want to find the inverse of 8x, and I want to verify that they are inverses of each other, well, I'm going to start off first off writing this as y equals. Then I'm going to swap the x and the y. Then I'm going to solve for the new y. So to solve for that, I'm just going to divide by 8. And then when your final step is to replace it with that inverse of f symbol. There's your inverse. Now to confirm it, you need to do substitution. So I'm going to do f of the inverse of f. So in other words, I'm going to take this 8x and plug the x over 8 into it. These honestly are fairly simple ones. You'll see real fast. The 8's will cancel off. You're left with just x. If you do it the other way, the exact same thing is going to happen. The inverse of f of x means I'm going to take this 8x and plug it in for this x, so I end up with 8x plugged in over 8. 8's cancel again, and you're left with x. So that confirms it. So sometimes you're given an asks you to find the inverse, sometimes you're just asked to do the confirmation. So these two functions, g and f, I want to show that they are inverses of each other. So what I'm going to look at is f of g of x, and I'm going to look at g of f of x. For f of g of x, I'm going to take the g of x and plug it in for the x. Well, that means I'm going to take the f function times everything in the g function. Now, honestly, with these linear ones, it's usually pretty obvious because you have very limited parts that will cross off very quickly. The 7's cancel, the 4's cancel, you're left with x. When I do the reverse, this 7x plus 4 in for that x looks a little strange to start, but 7x plus 4 minus your 4 divided by 7. Well, again, the 4's cancel first this time. You're left with 7x over 7. If those cancel, you're left with just x. So that confirms that it works both ways, and those two are inverses of each other. Graphically, what ends up happening is they actually end up being a reflection over that line y equals x, and it's usually the way I think about it. The nice thing about it is to generate it, you can actually just take all your coordinates and just swap the x and the y, or the a and the b, just flip them, and that'll generate your inverse from a graphing perspective. Sometimes that's the easiest way to generate it quickly. You can also solve for the equation if it's simple enough. So if I want to express the graph of f of x equals 4x minus 1 and its inverse, 4x minus 1 is going to be y-intercept of 1. You're going to go up 4 and over 1. So my line ends up being about right here. Its inverse would end up being just those points switched. So this point is at 0, negative 1. This point is at 1, 3. So I'm just going to swap those. 1, 3 becomes 3, 1. And 0, negative 1 becomes negative 1, 0. So when I draw that one, you can kind of see visually that they're over that line, y equals x. Now if you want to actually solve for the equation, y equals 4x minus 1, changes to x and y's, swap them. and solve for the new y. So x plus 1 equals 4y, and y equals, it'll be 1/4 x plus 1/4. And if it looks about to be a y-intercept of a quarter or so, and your slope is up 1/4. So it works. Alright, one more, like that. So let's get the graph of x squared plus 1 and its inverse. Well, x squared plus 1 is a little bit of a different piece because, well, parabola. Parabola is y-intercept of 1. So I'm going to put in an actual couple points here for reference. So if I go over 1, it's going to be up 1. If I go over 2, it's going to be up 4. And then, obviously, the symmetry over the y-axis. So my parabola looks roughly like this from my original. And yes, this is actually horrible, but my drawing skills are what they are. So, there's your original parabola. The inverse of that then, well, it's going to reflect over the line y equals 1, or y equals x, sorry. So, this point that's at 0, 1 is now going to be at 1, 0. I go over 1, up 1, that means I'm going to go up 1, over 1 from there. Left 1, up 1 means I'm going to go down 1, right 1. And then by the same token, I'm going to go over 2, up 4 from there. I'm going to go up 2, over 4. So about there and there. So you end up with your parabola that now opens horizontally. The other question is that a function? Problem is, no, it's not. So what did I skip? X is greater than or equal to 0. You have to watch out for this. The problem is, this thing doesn't actually have an inverse the way it is, because this inverse would not be a function. So what I need to do is actually only look at x is greater than or equal to 0. So I'm only looking at this right branch of the parabola. And as you can hear our new bells. So I have the right branch of the parabola. When that reflects, that's still going to be in the first quadrant. So this part goes away as well. Now, if you ignore those two parts, now you can actually have an inverse. Okay? And the quick way to test for that without actually drawing both and then realizing, oh crap, the second one is not a function, doesn't pass that vertical line test, is actually use something called the horizontal line test. The horizontal line test looks at the original function and tells you whether it has an inverse function or not. Okay, so if I go back up here, this original function, if I drew a horizontal line through it, would not pass the horizontal line test, therefore it does not have a function if I had the full parabola. Using only half the parabola, since x is greater than or equal to 0, that does work. Alright. One of the things, a one-to-one function has each value of the dependent variable corresponds to exactly one value of the independent variable. So that just means that if the function f has an inverse, it has to be a one-to-one function. And it just means pass the horizontal line test, pass the vertical line test, you're good to go. Alright, let's do a couple more examples real quick. Horizontal line test, is this going to pass or not? Well, if I graph it on the calculator real fast, it's just going to look like, oops, y equals, so I'll just put the numerator in parentheses. If you have a newer calculator, feel free to make it a giant fraction. But since it's linear, and actually you're pretty safe with this as long as it's not horizontal or vertical, it's linear, means you're going to pass the vertical line test, or horizontal line test, sorry. So I'm going to say that it passes horizontal line test. So f of x has an inverse. Okay. Going down here, negative 4x minus 9. Find the inverse. Well, first off, it's linear, so I know it has one. It's not vertical or horizontal. So to find it, again, y equals negative 4x minus 9. Switch the x and the y. Add the 9. Solve for the y. So I get negative 1/4 x minus 9/4. That would be your inverse function, so I'm going to rewrite it. Honestly, if you left it like that, it's fine. Otherwise, you can write it as negative x plus 9 over 4. Make sure that's negatives obviously out front of the fraction. You can write it a couple different ways. Either way is fine. Alright, one more. A little bit of an odd one. The original function is the cube root of 10 plus x. But the procedure is the same. It just looks a little funny at the start. So y equals the cube root of 10 plus x. Switch your x and your y. Then solve for the y. Now the problem is I need to peel off the outside layers. Okay? So I have the cube root. To get rid of that, I'm actually going to raise everything to the third power. So I raise this to the third, those will cancel. So I get x cubed is equal to 10 plus y. Oops. And then subtract your 10. And then finally rewrite it as the inverse function of f. Not too bad overall. Some of them do require a little bit of writing. That's a 1-minute warning bell. You'll get used to that this year. That's about all she wrote. See you tomorrow.